Hi everyone, Assalamualaikum. So today we are going to teach you subtopic 3.3 about Cramer rule, volume and linear transformation. In Theorem 7, we learned that n variables x1, x2, x3 and xn written in form ax equals to b. A is coefficient matrix, must be in square matrix. X is column matrix with variables. B is column matrix with the constants. So we let A be an inversible matrix and times n matrix. Then we find the determinant of A. D equals to determinant A, dx1, dx2, dx3 and dxn. So dx is the same determinant as D such that the column is replaced with B. Thus, x1 equals to d1 over d, x2 is equal to d2 over d, x3 equal to d3 over d. As you know, multiplying A by the identity matrix I will give back the column of A because identity is like pointer that picks out one column at a time. A I bracket B, you replace the ith column of A with vector B and it will look like A3 bracket B equals to bracket A1, A2, B, A3 and AN.
Cramer's rule is a method that allows us to find the solution to a system of linear equation using determinants. Let's take a look at an example to understand how it works. We are given the following system of linear equation. Our goal is to find the values of x1 and x2, which are the solution to the system. First, we need to write the system in matrix form. We express the system as Ax equal to B. We will create two new matrices, A1 and A2. For A1, we replace the first column of the coefficient matrix with the constant from the right hand side. And for the A2, we replace the second column of the coefficient matrix with the constant. To solve this using Cramer's rule, we need to calculate the determinants of the coefficient matrix and two modified matrices. Now that we have the determinants, we can apply Cramer's rule to find the value of x1 and x2. To find x1, we use the formula x1 equal to determinant A1 divided by determinant A. And to find x2, we use the formula x2 equal to determinant A2 divided by determinant A.
Formula for A inverse. Ej is the column of identity matrix and the ith entry of X is the ij entry of A inverse. This is the formula for ij entry of A inverse. By Cramer's rule, Ai bracket Ej bracket is the matrix obtained by replacing the ith column of A with Ej. Then, we use the cofactor expansion to prove the determinant of Ai bracket Ej. Aij is a minor of A, means it's the determinant of the matrix obtained by deleting the jth row and ith column of A. Cij is the cofactor of A at position, bracket Ji.
Now we're moving on to Theorem 8, which is a formula to find an inverse of a matrix. This formula can be used rather than using the long way ERO. The formula is A inverse is equals to 1 over determinant A times by adjugate A. The adjugate A or the adjugate matrix is the transpose of the matrix of cofactors.
For the first step, to find the inverse matrix A, we need to make the determinant of A. Find the determinant of A, we can choose any row or any column from the matrix A. So for this question, I use the row 1. Next, we find the cofactor to matrix A. To find the cofactor, firstly, we need to put the sign of the matrix. To find the cofactor transform is the interchange row and column from the cofactor. The last step, we substitute the value of the determinant and the adjoint A to the formula A inverse equal to 1 over determinant A times adjoint A.